Async code in Python has a reputation for being difficult to write, since all your async code has to be in its own separate code path and it has to follow async behaviors. Anything that makes async easier to work with is going to be a welcome addition to a Python developer's tool belt. That brings me to NeIO. NeIO is a third-party library that sits atop Python's existing async IO system, or it can use the earlier Trio library for async if you choose. It provides you with conveniences for many common async patterns, like tasks, or grouping tasks and canceling them as a group, or working with threads and subprocesses. It also gives you mechanisms for things like async file IO, which isn't available by default in Python. To give you an idea, let's dive into some examples. I should note that NeIO requires you to have some idea of how async works in Python to begin with, so I'm going to skip the basics and go right to how to accomplish common things. So in this program, we have a simple example of how to launch an async portion of a program from its sync portion. In NeIO, it's surpassingly simple. You just use the run method, and you pass to it the async function that you want to use as an entry point. Also, many common async functions are reproduced in NeIO from their async IO counterparts, like sleep, for instance, and they work very much the same way, as shown here. In Python 3.11, async IO gained a feature called task groups. This was a way to use a context manager to handle setting up and tearing down tasks. NeIO has a similar feature, and we can use it to launch multiple instances of a given async function. So this async with here, this gives us a task group object inside which we can launch 5 instances of some task. All of them must run to completion before we leave the context block. And as you can see when we run this, the finished message only comes up after all the tasks are complete. So this gives us a mechanism for ensuring some set of tasks can run and finish. Task groups in NeIO also give us some features that we don't have in async IO's task group system, at least not yet. For instance, with NeIO, we can cancel all of the tasks in a group at once, or we can start tasks synchronously or asynchronously in our code. Another feature worth showing is automatic cancellation of tasks after a given timeout. In NeIO, that's also done with a context. In this example, I'm using moveOnAfter. This is a context object that will cancel the tasks started in it if they don't complete after a given number of seconds. So when I run this, here's what happens. Our tasks, which all take 5 seconds, will get launched, and then moveOnAfter will wait a maximum of 1 second after the launch before stopping automatically. We can detect if the cancellation took place and use that to stop our tasks as a group. There's also provisions for trapping exceptions raised from tasks and finding out what they are if you want to do more advanced cancellation processing. NeIO also offers ways to run code in threads or subprocesses. For instance, if you want to run some synchronous code in a thread and wait for it to complete, you can use the toThread.runSync method. This will execute a sync function and pass it parameters. And this will cause the coroutine itself to block, but any other coroutine tasks that are running will still continue to execute. So this code will set up the coroutine tasks to start with, and then it blocks the execution of the main function, but these already launched tasks will continue to execute in the background. See, note when we see main sleep starting and finishing, that sync sleep of the main runs in a separate thread, so it doesn't block any of the already launched tasks. Another thing we can do with NeIO is perform file operations in a non-blocking fashion. File IO is synchronous in Python, but NeIO lets you do file work and coroutines without blocking your main thread. In this simple example, I'm using NeIO's path object, which is an async version of the pathlib.path object, to iterate through the current working directory and get each file. And then I use async with and await to open an async file object using NeIO's openFile method, and I can await each read from the resulting file object. So if I run this, you'll see that we have the contents of all the Python files in this directory printed to the console asynchronously. I should note that there is no async support for a print function, at least not yet. I'm not sure if that's even feasible. It would be a nice to have, but for the time being, we can do file operations asynchronously very easily. So there's a quick rundown for you of NeIO, which makes many common tasks with async easier, and it adds a few tasks that aren't available in the standard library for good measure. And that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.